multiple choice questions on microprocessor we are taking. Whenever a non-maskable interrupt occurs in 8085 microprocessor, which of the following data line contains the data? Now interrupts are of two types. First is maskable, second is non-maskable. Non-maskable means they cannot be disabled or ignored. The microprocessor has to cater to it, has to handle it. Trap is one of that kind. And maskable can be ignored, it can be delayed. So the answer here is D, because trap interrupt is a non-maskable interrupt and it has the highest priority among all. So when it happens, its vectored address is 0024, which is in hexadecimal. This is placed where? On the program counter. You know, program counter always have the address of the next instruction to be executed. So this 0024 will be placed in the program counter, and the 0024 is the lower address bus, which is also acting as the data bus. As I told you, AD0 to AD15, this is the whole the address bus, and the 8-bit part is used for the data bus as well. So here the answer is 24H. What does a microprocessor understand after decoding opcode, operation code? So any operation has two parts. The parts are opcode and operand. Opcode also has inside it, means the microprocessor understand that what is the addressing mode and what data it is going to act, how the data will be accessed is the addressing mode, and the data will be called as operand. Okay. Now the question is, what does a microprocessor understand after decoding the operation code? So for example, we have LDA, add, move, all these are instructions. So to decode this opcode, what do we get? So after decoding the operation code of the instruction, a microprocessor understands the length of the instruction, 1 byte, 2 byte, 3 byte, and the total number of operations to be performed, because there are different T state in instruction cycle. There is memory write, memory read, fetch, all these are done. So the answer here for this particular question, what does a microprocessor understand, is C, length of the instruction and the number of operations after decoding the operation code opcode. How many address lines are present in 8086 microprocessor? See, this is not 8085, this is 8086. In 8085 we have 16 address lines. This is the answer is true, 16 for the 8085. But we are talking about the 8086 here. Okay, the difference is, you see this picture. This picture shows the 8086. So from AD0 to AD14 you see here, and then we have AD15 till AD19. That means if we start with 0 and go up to 19, that is 20 address lines are there. So AD0 till AD19 we have. So how many address lines? 8086 microprocessor, though it is a 16-bit microprocessor, it uses 20 address lines and 16 data lines. 20 address lines, AD0 to AD19, and 16 of them are used also for the data lines. And you know, whenever the data lines is talked about, that is the bit processor side, 16-bit. Which of the following is not a status flag in microprocessor? In microprocessor, we have different flags. Sometimes ALU operation is happening. Then what is the result? What is whether it is 0, whether carry is there, whether the sign has changed or sign is positive or negative. So these are different flag register in an 8-bit flag register which only use 5 bits. So answer here is the index flag, because the overflow flag represent whether the result is out of scope or not, that it has spilled over or not, means it has Does the boundary it is out of bound or not? Something extra has not come. Direction flag is used in string operations. Direction flag, string operation like concatenation, etc. Some part is taken. And the interrupt flag is used for enabling and disabling. That is, it is used to enable the interrupts. IF flag, interrupt flag. Okay. So the answer here is D, index flag. Which of the following is not a condition flag? Not a condition flag. So again, I am telling you, these are all the flags. So these, all the flags which you see here in the diagram, they are called condition flag. Sometimes the result comes all 0. So 0 flag will become 1. And then we have sign flag, 0 flag, auxiliary carry, parity, carry flag. All these are the conditions flag. Please remember, certain ALU or arithmetic logical operation, there will be some result. So all these you see are condition flag. The question is asking not a condition flag. Now the trap flag, the direction flag and the interrupt flag, these are all called the control flags. So this A trap flag is a control flag. It is not a condition flag. So the answer will be A. It is not a condition flag. Okay, trap is the answer. Which of the following register is not used in opcode fetch operations? Not used in opcode fetch operation. Okay. See. So any instruction will have two parts. The operation code opcode and the operand. Opcode and operand. So which of the following register is not used in opcode fetch operation? So flag register, this is not used in opcode fetch operation because this flag register is used to represent the, for example, some operation LDA is there. So this is used to represent the status of arithmetic and logic operation which is performed after decoding the opcode. Once the opcode is decoded, then it is done. Okay, for fetching operation, flag won't be used. Once all things are done, then some operation is performed, then all the flags will be affected, otherwise, or they are used. Otherwise, fetching the opcode won't. Though this program counter, the memory address register and memory data register, all these three, they will be the part of fetch operation, not the flag register. Okay. A memory connected to a microprocessor has 20 address lines and 16 data lines. What will be the memory capacity? So, will you be able to do it? Okay. Let us see the solution. If you have got it right, congratulations. 20 address lines are there. So you have to address, that is 20 address lines. The addressing capability is simply 2 raised to the power this number of address lines. For example, 8-bit, 2 to the power 8, 16-bit, 2 to the power 16. So 20 address lines, we already found in 8085 it is 64K. Here it is 2 to the power 20. Now this 20 are the location, but every location, because it is given that it has 16 data lines, that means we are talking about 2 bytes. Please remember, we are talking about not 16 data lines means 16-bit. 16-bit means 2 8-bits. 1 8-bit is 1 byte. So we are talking about 2 bytes. We are talking about 2 bytes, right? So here we have to multiply this 2 raised 20 with 2 in order to get the final answer. So we have to multiply this 2 raised 20. It is not the total answer, 2 raised 20. We need to multiply it with the 16 data lines, that is 8-bit, 8-bit, 2 bytes. So this 16 has come from 2 bytes. We are going to address this 2 byte location because 220 into 2, and that is going to be 2 megabyte. And you know about 2 raised 10. 2 raised 10 is 1024. That is considered to be 1000. 1024, actually 1024 is 1 KB. Then 2 raised 10, 2 raised 10, because 2 raised 20 is 2 raised 10 into 2 raised 10. So 1 KB, and then again 1000 is 1 MB. So we have a megabyte here. So 2 megabyte is the answer. 2 bytes, see, megabyte is there, so the answer are in megabyte. What is the word length of the Pentium 2 microprocessor? Now this is a random question because Pentium 1 can be asked, Pentium 3 can be asked. You must have certain idea about all these Pentium processor. The answer is the Pentium 2 is a 64-bit microprocessor. The 64-bit microprocessor, it was introduced in 1997, and the only thing 64-bit is representing is that it has 64 data lines. So 7.5 million, 1 million is equal to 10 lakhs. 7.5 million transistors were there, and the word length was 64-bit. Which of the following is not true about 8085 microprocessor? Not true, we have to ask. So 8085 microprocessor, it is an 8-bit microprocessor, we know that. Initially, the microprocessor was launched and it was just a paradigm shift. After that, all the processors came. It has 40 pin, we know that it has 40 pin. It has 16 address lines, we also know that. Now comes here is PMOS. So not true is PMOS, because the 8085 microprocessor is manufactured using NMOS technology. PMOS technology were used in 4004 microprocessors. So NMOS technology is somewhat faster than this PMOS technology. Which of the following is a non-vectored input? Non-vectored input. Let me give you the answer first, then we'll talk about that. Please remember, the trap is always the highest priority. So we have the software input interrupt and the hardware interrupt. Software interrupt is coming from the software itself, that is the program itself. Hardware is coming from the peripheral devices or the devices which are connected. So vectored and non-vectored means, vectored means it has a proper address. Trap has to be handled. This RST 7.5 till 5.5 and INTR also. But this trap is having the highest priority. It is both edge and level triggered, while the RST 6.5, RST 5.5 and INTR are level triggered. RST 7.5 is edge triggered. The only trap is non-maskable, others are maskable. So this column vectored, so every one is vectored except INTR. So all the vectored have fixed address. See, the program counter will know what address to be placed. But the INTR has a range of address. That is, any address can be taken from here, and that has to be provided by the external device. User will not provide it. System will not provide it. It has to come from the external device. That is why it is a non-vectored input. If it would have been say RST 7.5, so it has a proper address 003C. So trap, RST 7.5, 6.5 are vectored inputs. INTR non-vectored. Which of the following is true? Which is true? So let us see which are false. Every instruction has two parts, opcode and operand. We know that opcode it by itself is having the idea about the addressing mode. Addressing mode is all about the data to be found out. Of data is called as operand. Opcode is the operation to be performed. So first one is true. That means the others have to be false. See, move BC is 2-byte instruction because there is no data present. It is just B, C. It is a 1-byte instruction. Since in MVI we have 98, that is one data is present. So it is a 2-byte instruction. So the B is incorrect because it is given 2-byte, but it is actually 1 byte. MVI is 3-byte given, but it is actually 2-byte, right? And maximum number of T states possible for the execution of an instruction is 16. See, the T state, most of the T state is taken by call. So if you see call, there are multiple things happening. 6 T states for operation fetch, then memory write, then 2 for the pushing onto the stack. Then we have memory read, again for new value of PC fetch from memory. If you combine them, there are 18 T state for call operation. So it is 16 given. So that is why it is wrong. Which of the following addressing mode is used by 8085 microprocessor for array and list operations? See, whenever array and list operation comes, you just have to think about indexing. Because array is all about index, which place the data is stored. List is all about which place is data stored. So array starts with 0. Then there has to be some indexing. That is, we have to start from here and then go up to which point. So let me tell you about the answer. It is C, index. As I just suggested, it is index. So this indexed addressing mode is used for array and list operation. It uses a constant value and index register to execute the final instruction. That is why the answer is indexed. What is stored in the HL general purpose register? See, general register we have B, C, D, E and HL. So this is basically having the address of memory. H, 8-bit register, L, 8-bit register. But if you combine HL, they work as a 16-bit pair. So H and L are 6-bit general purpose register. They are used to store the address of the memory. And as I said, together if you combine 8-bit, 8-bit, they can store 16-bit address, and the address of memory is the answer. If a 90 GB memory has to be connected to a microprocessor, minimum how many address lines are required? That means the address lines 2 to the power something has to be somewhat equivalent to 90 GB. 90 GB, we have to see what are the numbers. So 90 GB lies, and every number is of 2 to the power. So 2 to the power n is the main scenario here. Now see, 90 GB comes between the 64 GB and 128. This is all 2 to the power. 90 GB is coming in between. Now, 64 GB is nothing but 2 to the power 36 bytes. If you compute it, it will be 2 to the power 36. This is your 64 GB. Now, in order this, just add 1 to the power. If you add 1 to the power 2 to the power 37, that is 64 GB multiplied by 2. How it will be? That is going to be higher than 64 and lesser than 90 GB. That is, we just have to add 1 more to the 36. That is 37 lines. If you want to connect a 90 GB memory to microprocessor, minimum 37 address lines are required. Which of the following is a software interrupt? See, there are 2 types of interrupt: hardware interrupt and software interrupt. Hardware interrupt is coming from external signal, that is, some hardware is giving interrupt. Software is a special instruction which comes up as the result of the software itself, or the language itself, or the program itself. There are certain maskable interrupt that can be delayed or rejected or ignored. There are certain non-maskable interrupt that cannot be delayed or rejected. That is, trap is a maskable interrupt, others are non-maskable. Trap is a non-maskable, others are maskable. Vectored and non-vectored. Now, vectored means where the subroutine starts the location. If the location is known, we call it as a vectored. If we don't know the location, the address of the service routine needs to be supplied by the device, then we call it as non-vectored. So the answer here is D, RST5. Because software hardware interrupt, there are difference. All these 5.5, 6.5, these are all hardware. Software is 5, 6, 7 like this. I'll just show you the whole series. But let me tell you, trap, INTR, RST 6.5 are the hardware interrupts. But the RST5, this is a software interrupt. Okay. Let me give you an idea about hardware and software interrupts. The hardware interrupt, these are used to handle the asynchronous events. That is, those which are not in they are not synchronous. They are happening anytime. Both are happening anytime. Software interrupts cannot be used to handle asynchronous events. So hardware interrupts, they are requested by the peripheral device or the external device. The software the interrupts, they are requested by microprocessor itself and through certain programs, certain code, certain instruction. These are software interrupts. Hardware interrupt, after execution of these interrupts, the program counter is not incremented because it is just a hardware interrupt. Okay, once it is executed, it is not incremented. While the software interrupt, after the execution of these interrupts, software program counter is actually incremented. So some hardware interrupts, they are maskable, like we just saw 7.5, 6.5, etc. Software interrupt, all the software interrupts are non-maskable. Though they have high priority, please remember software interrupts have higher priority than hardware interrupts, but all the software interrupts are non-maskable. While hardware interrupts, some hardware interrupts are maskable, but they have lower priority as compared to the software interrupt. And as I said, the hardware interrupt, it improves the throughput because the devices are giving the instruction or the interrupts. Software interrupt, they don't improve the throughput because a microprocessor will be busy in handling that again and again. And as I said, that this will definitely affect the interrupt control logic, hardware interrupt. The software interrupt won't, this will not affect the interrupt control logic. So let me give you an example of hardware interrupt. Trap, RST 7.5, 6.5, 5.5, INTR, these are all hardware interrupts. And RST 1 till 7, 1, 2, 3, 4, 5, 6, 7, these are all software interrupts. What is the vector address of RST5? So this answer you have to give because we are going to take in the next discussion. Thank you so much.